Welcome back to another video, guys, and today I will teach how you can solve linear equations using Gauss Seidel. Yes, you can solve these sort of equations using the Gauss Seidel method, and it's very easy. I'm going to tell you exactly everything you need to know about Gauss Seidel, so make sure you watch this video in its entirety. So let's begin. It is the most commonly used iterative method to solve linear algebraic equations. Okay, so it's well suited for a large number of equations, but you have to be careful. Before we start the method, I want to tell you something really quickly. The most important part about Gauss Seidel. So you must make sure it's diagonally dominant. Okay, remember this, diagonally dominant. I'll explain that in a bit. So let's go for an example. Let's go for this example. Okay, so over here you want to rearrange for x1. Over here, you want to rearrange for x2. Over here, you want to rearrange for x3. This is diagonally dominant. Okay, diagonally dominant. What diagonally dominant means is you do 0.1 plus 0, well, minus 0.2 is less than this. These two added is less than this. These added is less than this. So it's diagonally dominant. The other sides will add up, but they'll be less than the diagonally dominant. The diagonally dominant is 3, 7, and 10. So you rearrange for these variables x1, x2, x3. You rearrange them like this, and then you start initially the first iteration. All of them are 0. So you substitute 0. So x1 is x2, x3. So these are 0, 0, and this is 0. So you put 0, 0 here, and then you get this. So now this is the x1 value, the new x1 value. So then you will use 2.616667, and then you'll 0. Okay, for x3. So for yeah. And then you'll keep going. Now you got the new x2 value. Then you use the previous x1 x2 values. You update the x1 x2 x3 after each iteration. Okay, you update. So these are the new x1 x2 x3 values. You put them again for the second iteration, and then you can use the error formula to calculate the difference. Now remember, if we look at another example, okay, this is another example. The upward velocity of a rocket is given at 3 different times. 500, and so this is the times, just some stuff here, and this is the equation a t squared a t cube. Okay, so using the matrix template of the form, so we can do t squared, t1 and 1, and then a1 a2 a3. So these are the unknown coefficients, and we can just set them up like this. Now initial guess, we can start 1 2 3. Okay, so we rearrange for 25, so a1, and then we rearrange for a2 like this, and a3 will be down over here. Now there'll be a problem here because this is not diagonally dominant, and I'll tell you why it's not diagonally dominant in a bit. Okay, so when you keep going, you do the iterations, you will see that it's not actually converging. So this is the first iteration, it doesn't converge. Look at the second iteration, it doesn't converge. It's not converging. Look, first you got like 3.672, now you're getting like 12.605, so it's not converging. Yeah, so what is the pitfall of the Gauss Seidel method? This is the most important thing. The pitfall is that it has to be diagonally dominant. Okay, like I said, diagonally dominant is like this. So 25, 8, and 1. This is the diagonal. 5 plus 1 is 6. Is that less than 25? Yes. Then what's diagonally dominant over here? 8. Okay, 1 plus 64 is 65. Is that greater than 8? No. So this whole thing cannot be diagonally dominant. 1 plus 12, is that greater than 1? No. Whatever is here has to be greater than the other two combined. Do you get it? And if that's the case, then Gauss Seidel method will converge. But if that's not the case, it's not diagonally dominant, then it won't converge, and we will have a problem. As you can see, which coefficient matrix is diagonally dominant? 3, 0. This or this? This one's not diagonally dominant, as you can see. This one is diagonally dominant because 0.3 minus 0.2 gives you this. 0.1 plus minus 0.3 is less than 7. 0.1 minus 0.2 is less than 3. So it works, and all of these work. This is diagonally dominant and this is not. So yeah, guys, so make sure you keep this in mind. And also, if you want to get some like if you want help in anything, to get like services and stuff, you can go to a site called Fiverr. Click on the link in the description and you will go to this site, okay, and you can hire literally anyone over here. Okay, thank you so much for watching, and yeah, bye bye.